To make electricity easier to understand, let's think of a simple plumbing system. Imagine you have a water tank, a pipe, and water flowing through it. In this picture, electric current is like the flow rate of the water. It tells us how much electricity is passing through a point in a wire every second. We measure this in amperes, or amps for short. It's similar to measuring how many gallons of water flow out of a faucet in a minute. Of course, if there's nothing pushing it, the water won't flow. In our plumbing system, that push comes from a pump or a high water tank creating pressure. In the world of electricity, this pushing pressure is called voltage. Voltage is the force that moves tiny electrical particles, which we call electrons, from one point to another. Think of it as the energy difference that makes everything start moving. So what about the wires? Well, electrical wires are just like the water pipes. Water flows easily through a big, wide pipe, but it struggles to get through if the pipe is narrow or has a blockage. This blockage or restriction in electricity is called resistance. We measure resistance in OEMs, materials that let electricity flow easily, like copper, have very low resistance. They're like super wide pipes. On the other hand, something like a light bulb filament is designed to have higher resistance. It's like a narrow nozzle in the pipe, which slows the flow down and, in the process, converts electrical energy into light and heat. Now, let's see how these three things, voltage, current, and resistance, are all connected. This relationship was figured out by a scientist named Georg Simon Ohm, and it's now one of the most fundamental rules in all of electricity, Ohm's law. It's actually quite intuitive. If you keep the pipe the same size but increase the water pressure, what happens? The water flows faster, right? In electricity, it's the same. If you increase the voltage while keeping the resistance the same, the current will increase. Now, what if you keep the pressure the same but make the pipe narrower? The water flow will slow down. Again, it's the same with electricity. If you increase the resistance while keeping the voltage the same, the current will decrease. This simple, powerful relationship is what Ohm's law describes. The famous formula for Ohm's law is voltage equals current multiplied by resistance, or V equals I times R. This means the push you need is determined by how much flow you want and how much resistance is in the way. It's the simple but elegant rule that governs how every basic circuit works, from the charger for your phone to the lights in your room. It's the ABC of electricity. So, to recap, voltage is the push, current is the flow, and resistance is the restriction. Understanding how these three work together is the first major step to understanding the amazing world of electricity. Thanks for watching, and if you found this helpful, don't forget to like and subscribe for more simple explanations of complex topics. See you in the next video.